channel. Get understanding, don't memorize. This is the continuation of a series of lessons on binary operations. Binary operation in elective mathematics or further mathematics. So yes, in this video we look at the definition of what? Definition of binary operation, definition of closure. We still consider some more examples to buttress our explanation in order to solidify our understanding. So we are saying that also consider the operation of division. So we are considering the operation of division and what? On the set of what? Natural or counting numbers. Consider the operation of division on the set of natural or counting numbers. That is, if you have the set of other natural numbers, so we're counting natural numbers the same, counting 1, 2, 3, we are counting. So if we say start counting, we count from 1 to then we are going. So set of natural numbers or counting numbers is made up of 1, 2, 3, 4, 5 to infinity. Then we are saying that out. And then we are looking at what? The operation of division under this set, okay? Set of natural or counting numbers. So division. So we take two elements. We are taking two elements, okay? In this case, we are taking 2 and 4. 2 and 4. Then 2, and we are dividing them 2 and 4. So 4 divided by 2, we are getting an answer for 2. So what is 2? 2 also belongs to the set of natural numbers. Okay? We take 2 elements, 10 and 5, we divide, we get 2, which also belongs to the set of natural numbers. And then this same 2 and 4 we can divide. Instead of dividing 4 by 2, we can divide 2 by 4. And then we are getting half, 1 over 2. But 1 over 2 does not belong to the set of natural numbers. And the same with 3 over 9. 9 over 3 will give you 3, which is part of a set of natural numbers. But 3 over 9, which is 1 over 3, does not belong. So this is the set notation of what does not belong. This is belong. And then if you cross it, that means does not belong. Okay, I hope you know that if you taught sets. Okay. Then we are saying that so 1 over 3 does not belong to the set of natural or counting numbers. Hence, the set of natural or counting numbers is not closed. It's not closed under the division operation of division. Why? Because if you take 2, for every 2 elements belong to this set of set n, if you apply the operation of division on these 2 elements, the result is always not what? Always not a member, or the result does not always belong to the set of natural numbers. Yes, the example is what 3 and 9. Or 3 and 9, if you 3 divided by 9, we are getting 1 over 3, which is not a set of this, which is not a member of what a set of natural numbers. Hence, we are saying that what the operation of the set of natural numbers n is not closed under the operation of what addition. So we are saying hence the set of natural numbers or counting numbers n is not closed under the division, under division or the operation of the. Hence, if it is not closed under the division operation, then we are saying that the operation of division is not what? It's not a binary operation on the set of natural or counting numbers. So we have to know this. So before any operation can be a binary operation on a particular set, then that set must be closed under the binary under the operation. The set must be closed under the operation before the binary the operation can be a binary operation on with respect to the set on the set. Okay. Yes. So that's what we are saying. Also, the operation of subtraction is not a binary operation on the set of positive integers. Why? P. Why? Because it means if we are saying also the operation of subtraction is not a binary operation on the set of positive integer P. Why is it that the operation of subtraction is not a binary operation on the set P? Because the set P is not closed under the operation of subtraction. So this set is not closed. Why is it not closed under the operation of subtraction? Because it could be that we can take 2 elements of this set P. If you subtract them, the answer we get will not be an element of this P. That's what we mean. So if this set is closed under subtraction, it means that every two element we take from this set, if you apply the operation of subtraction, the result we get must be a member or belong to set P. And if that happens, then we are saying that the set P is closed under subtraction. And if the set P is closed under subtraction, then we are saying that the operation of subtraction is a binary operation on this set what P. That's what we are saying. So we are saying that operation of subtraction is not a binary operation on the set of positive integer P, which is positive integer 1, 2, 3, and to infinity. Why? Because the set P is not closed under subtraction. That is why is it not closed. That is what for if you take 2 elements belong to the set of positive integers or P, 4 and 6 in this case, and we subtract 4 from 6. 4, that is 6 minus 4. We get what 2. 2 is part of what? A set of positive integers. 2 belong to that. So this is holding. This holds. But how about if you subtract 6 from what? 4? The other way, we got what? Negative 2. Is negative 2 a member of positive integers? No. So despite the fact that 6 with the same two elements, 4 and 6, or 6 and 4. If you subtract 4 from 6, we get 2, which is a member of this. However, if you subtract 6 from 4, we get negative 2, which is not a member of P. Therefore, the set P is not closed under subtraction. In other words, the operation of subtraction is not a binary operation on the set P. Also, if you take 3 and 8, we take 3 and 8. Though 3 and 8 belong to P, but 3 minus 8, you get negative 5, which does not belong to P. Hence, the operation of subtraction is not a binary operation on the set of positive integers P. In other words, the set of positive integers P is not closed under what? Under the operation of subtraction. Guys, this is not difficult at all. I'm trying to, give more examples so that you really understand. I hope you really understand it. If you don't understand anything, don't forget to let me know. Don't hesitate to let me know. If you also understand it, if you have this has been clarified any issue for you, then subscribe to let me know that you are benefiting. And don't forget to share it, and like it, share it with your friends. Thank you guys for watching, and see you in the next video, guys. Hello students, here is a continuation of our series of lessons on binary operation in elective mathematics or further mathematics. So in this video, we are going to look at if you say a binary operation is a binary operation, and then we say that a set is closed under or with respect to a particular binary operation in the previous video. So in this video, we are looking at define binary operation. So we said in the previous video, as we were saying, that the usual or normal operation that we use with our addition, subtraction, multiplication, or division. So these are the usual operations. Whatever you talk about operation, these are the operations that will come to mind. However, if you want to define our own, special operation, then we can define the operation as a star, triangle. We can even have this triangle inverted like this. We can have square like this. So we can define this operation, this special operation, in terms of what the usual operations we do. We are saying that the common and usual operations are addition, subtraction, multiplication, or division. Therefore, if you want to use more than one of these operations, if you want to use more than one of these operations of addition, subtraction, multiplication, and division at the same time, then we have we have to define it. Yes, because this operation then we have to define it. Okay, so we are saying that, for example, the operation you want to define is star. You are using star, and then we want to use more than one of these usual operations. More than one at the same time. So we are saying that star, you're having two elements, A star B is equals to 2AB. This is what operation are we using? The usual operation, you are using multiplication minus into bracket A plus B. So where A and B belong to the set of real numbers. Yes. So this A and B, this operation star is defined on the set of real numbers. Yes, that's what. So we are using usual normal operation are we using? We are using multiplication, subtraction, and addition. We are using these three usual operations at the same time. To define our own operation star. Also, if you have x0 y is equal to s plus 1 minus 1 over 2 sy, where s and y belong to the set of belong to the set of real numbers. So this operation, operation that we are defined is involves addition, subtraction, and multiplication. Okay, these are all defined binary operations. So they are all defined binary operations. So usually binary operation, this is how you usually see this operation. The defined operation. Yes. So that's what the binary operation normally involve. So note for A star B, which is equal to 2AB minus bracket A plus B. AB belonging to R. AB belongs to that. We can be asked to evaluate 2 star 3, and 4 star 1. Okay, we can be asked to evaluate them. Okay, guys, so let us look at how we evaluate them, guys. Thank you. Yeah, students, as we are saying, yes, these are all examples of defined binary operations that involve more than one of the usual operations we know. Okay, so we are saying that whenever the operation is defined like this, you can be asked to evaluate or simplify. For example, you can be asked to find 2 star 3, 2 2 star 3. So what is this? Is definition of the operator, definition of the binary operator that involves the operation of a star. So if you are to find 2 star 3, it means that 2 star 3, this one is equivalent to what? A star what? A star B. So it means that here A is equal to what? 2, and what? B is equal to 3. So whatever you see A, you put 2 there. Whatever you see 3, you put B, you put 3 there. So everything. So this means that 2 star 3, 2 star 3 will be equal to what? 2. This is 2 times what? Times A. A is what? 2 times B. B is 3. Minus what? To bracket A. A is what? 2 plus B. B is what? 3. So this is what. So we have 2 star 3, which implies that A is equal to what? 2 and B is equal to 3. So 2 star 3 will be equal to 2 times what? A times B, which is what? 2 times 3. Then minus what? 2 plus 3. And 2 times 3 is 6. 6 times 2 is what? 12. So we get 12 minus 5, which is what? Which is 7. Okay. And then let us also, we can also be asked what? To find, let's see, 4 star 1. So 4 star 1 is, it means that A is equal to what? A is equal to 4 and B is equal to 1. So which is 2 star A star B, which is 2 AB. In this case, 4 star 1 is equal to 2 times what? 4 times what? Times 1 minus 4 plus 1, which is what? 4 times 1 is 4. 2 times 4, 8. So we get 8 minus 4 plus 1 is 5, which is equal to what? 3. Okay. This is very simple. It's not difficult at all. Otherwise, you can also be asked what? To find 2 star. You can be a 2 triangle what? Or 2 not. Sorry. You can be asked to find 2 not what? Not 1. So this is equal to me that S is equal to what? This 2 is, and the 1 is equal to Y. So which is equal to S plus Y. So it become 2 plus what? 1 minus what? 1 over 2 times what? 2 times 1. Okay. So 2 will cancel these 2. So we get 2 plus 1 is 3 minus 1, which is equal to what? 2. At the end of the day, this is what we get 2. Okay. So guys, in fact, you look at more examples of this nature in the subsequent videos. Okay. Yes. So don't forget to subscribe to the channel if you are getting understanding. Don't forget to share with your colleagues and friends. Don't forget to like it as well. Thank you for watching and see you in the next video.